Hello students, welcome to the first session of the rapid revision in mathematics for your subjective questions of mathematics grade 12 examination. So today we'll be discussing on the topic of matrices, determinants and also questions from linear programming. And you have gone through the sample papers, I guess. Most of the questions from matrices and determinants are MCQ based, and we are expecting at least 1 2-mark question or a 3-mark question, and maybe also one 5-mark question is expected from this unit of matrices and determinants. Okay, so if you have not seen the MCQ discussion, please go to the previous video. You can see the MCQ discussion on matrices and determinants. So here I'll be discussing only the subjective questions in matrices and determinants. So again, students, let us go to the question straight away. The first question here is, express the following matrix as the sum of a symmetric and skew symmetric matrix. They have given me a matrix A. You are supposed to express that as the sum of a symmetric and skew symmetric matrix. Easy idea. First of all, symmetric means, keep in mind, it is always A plus A transpose. Skew symmetric means it's always A minus A transpose. The best way to convert a given square matrix into a symmetric matrix, some symmetric matrix, is simply add the matrix with its transpose. If you subtract the matrix with its transpose, you will get a new skew symmetric matrix. First of all, let's find the transpose of this given matrix. I hope everybody knows how to find the transpose. Make each row the column of the matrix. Yes, so it's going to be what? The first row becomes the first column, minus 1, 2, minus 5. Second row becomes the second column, 4, 3, 1. Third row becomes 1, minus 3, and 6, the third column. Yes, now if you add these two, what do you get? What is A plus A dash? A plus A dash, minus 1, minus 2. 2 plus 4, 6, minus 5 plus 1, minus 4. 4 plus 2, 6, 3 plus 3, 6, 1 minus 3, minus 2, 1 minus 5, minus 4, minus 3 plus 1, minus 2, 6 plus 6, 12. I got the matrix A plus A dash, which definitely is symmetric. If you want, you can just cross check. Just look at the elements above and below the diagonal. It's exactly the same. Then it is a symmetric matrix. Now, form a skew symmetric matrix. Subtract A and A transpose. Minus 1 subtracted with minus 1 is 0. 2 minus 4 minus 2. Minus 5 minus 1 minus 6. 4 minus 2 is 2. 3 minus 3 0. 1 plus 3 4. 1 plus 5 6 minus 3 minus 1 minus 4 6 minus 6 0. Now how to verify whether it is skew symmetric? Again, the diagonal should be zeros and the elements above and below the diagonal should be of opposite signs. Minus 2 2, minus 6 6, 4 minus 4. So the idea is A plus A dash, A minus A dash. Now how to write this given matrix as the sum of these two? The idea is very simple. So A can be expressed as half of A plus A dash plus half of A minus A dash. Okay, half A plus half A is A. Half A dash minus half A dash cancels off. So how can I express A as the sum of a symmetric and skew symmetric? Half A plus A dash, half A minus A dash. Remember the equation, all of you? Half of A plus A dash, half of A minus A dash. So my matrices are half of this, minus 1, 3, minus 2, 3, 3, minus 1, minus 2, minus 1 and 6. Plus 0, 1, sorry, minus 1, minus 3, 1, 0, 2, 3, minus 2 and 0. This is a symmetric matrix. This is a skew symmetric matrix, and I have expressed my given matrix as the sum of these two. So it is expected for 2 marks. Good question for 2 marks from matrices chapter. Please learn it. Once again, symmetric means a plus a dash. Skew symmetric means a minus a dash. Keep in mind, it's a good question for MCQ also. Which of the following can be considered as a symmetric matrix? Which of the following can be considered as a skew symmetric matrix? Good question. A plus a dash, a minus a dash. Okay, and how to express it back as the sum of two matrices? A is equal to half a plus a dash plus half a minus a dash. Okay, going forward to the next question, my dears. A and B are symmetric matrices. Prove that AB plus BA is a symmetric matrix. AB minus BA is a skew symmetric matrix. This is a very old question, and it's a very common question in CBSE boards over the years. So you can just learn it. It's a very easy question also. I have to prove that AB plus BA is symmetric. So let me call it as P. P is equal to AB plus BA. And I have to prove that P is symmetric. How to prove that a given matrix is symmetric? According to the condition, a matrix becomes symmetric if the transpose of the matrix gives me the same matrix. If P dash equals to P. P is symmetric if P dash equal to P. So let me take P dash. What is P dash, my dears? P dash is the transpose of AB plus BA. Sum of two matrices transpose. What is the property of A plus B transpose? A plus B transpose is the first matrix transpose plus the second matrix transpose. Property once again, A, or if I say X plus Y transpose is equal to X transpose plus Y transpose. Now if I go for the product, AB transpose, you have to reverse the product and apply transpose. AB transpose is B transpose multiplied with A transpose, and BA transpose is A transpose multiplied with B transpose. But in the question it is given that A and B are symmetric. A and B are symmetric. So if A and B are symmetric, A transpose equal to A, B transpose equal to B. Apply that condition over here. So B transpose can be written as B, A transpose as A, and this is AB. So AB plus BA is same as BA plus AB, because sum of two matrices is commutative. Addition is commutative. So BA plus AB is same as AB plus BA, which we know is P. Proof done. I proved that P dash is equal to P. Hence, my matrix P is symmetric. Therefore, P is symmetric. So what is P? We already know. AB plus BA. Got it? This is how you prove that AB plus BA is symmetric. It's a very common question before for boards. You can study it. It could come. It's a good question to come. Now, if I go for skew symmetric, I want to prove AB minus BA. So let me call it as Q. Q is equal to AB minus BA. How to prove Q is skew symmetric? How to prove Q is skew symmetric? It is skew symmetric if the transpose is negative Q. A matrix becomes skew symmetric if its transpose is negative of that matrix. So here let us consider Q dash. The same technique, AB minus BA dash. Again, subtraction of two matrices, AB dash minus BA dash. The property of transpose says that if you subtract two matrices, you can simply apply the transpose on each of them. Now that is equal to again B dash A dash minus A dash B dash. This property I already explained before, the product. When you apply transpose on the product, you can reverse the product and apply transpose on each of the matrices. Now again, using this condition, A dash is A, B dash is B. I can say it is BA minus AB. Take the negative out, you will get AB minus BA. AB minus BA. And AB minus BA is definitely Q. AB minus BA is definitely Q. Okay, all of you clear? Q dash is equal to minus Q. Hence Q is skew symmetric. Hence Q is skew symmetric. Okay, I hope everybody is clear. Yes, so it's a very good question for 2 marks. You can learn it. One of them could be coming or both of them could be coming together. That is their decision to ask. Okay, so I believe the second question is very clear. Any doubts you can ask, or I can move forward to the next question, please. Okay, moving forward, students. The next question, please. Prove that BAB transpose is symmetric or skew symmetric. It can be symmetric or skew symmetric depending on whether A is symmetric or skew symmetric. It means that if A is symmetric, this matrix is also symmetric. Got it? If A is symmetric, BAB transpose is also symmetric. Or if A is skew symmetric, then BAB transpose is also skew symmetric. Okay? Let's start with the question once straight away. Let us consider BAB transpose. Okay? And I'm applying the whole transpose to it. What is the condition for symmetric? The matrix transpose is the matrix itself, and skew symmetric, the matrix transpose is the negative of the matrix. We know BAB dash is a matrix, a square matrix, and BAB dash transpose is equal to BAB dash. Then I can say BAB dash is symmetric, and BAB dash transpose is equal to minus BAB dash. I can say BAB dash is skew symmetric. That's the question. So I'm applying the transpose anyway. According to the product of matrices, let us assume these two first as a product, and the next one you have to reverse the product, right? The first matrix is going to be B dash, and you're going to apply transpose on that, and the second matrix is going to be AB, not AB, it's going to be BA, and you're going to apply transpose on that. Yes, the product of BA and B dash. The product of BA and B dash. Apply transpose, you get B dash dash BA dash. What is B dash dash? Transpose of a transpose is B. And what is BA dash? It is A dash B dash. Now, this is where we're going to divide it into two cases. Case 1, I'm saying if A is symmetric, no doubt A dash is A. If A is symmetric, A dash is A. Now what will happen to equation number 1 now? So equation number 1 is actually B A dash B dash, which can be replaced as B A B dash. So I took B A B dash, the whole transpose, and I got B A B dash back. Hence, from this I can conclude B A B dash is symmetric. So if A is symmetric, B A B dash is symmetric. Case 2, if A is skew symmetric, what is the condition for being skew symmetric, all of you? Skew symmetric says that A dash is negative A. Skew symmetric says A dash is negative A. So that implies what happens to equation number 1 now? B into A dash into B dash is equal to B into minus A into B dash. Can I take the negative out? It's minus of BA B dash. So I took BA B dash, transpose, I got minus of BA B dash when A is a skew symmetric matrix. Therefore I can say BA B dash is skew symmetric. That is what we need to prove here. It's a very good 2-mark question, my dears. How to prove once again? If A is symmetric, then BA B dash is symmetric. If A is skew symmetric, then BA B dash is skew symmetric. All of you, please learn it thoroughly. First, what you need to do is apply transpose and get the expression for it. And then start thinking, what if A in this is symmetric? What if A in equation number 1 is skew symmetric? Prove both of them and the question will be having both of them. If only one part is asked, prove only one part of the case, not the other one. Okay? So I believe everybody understood the question. Okay, guys, moving forward to the next one. Please read it. They have given me a matrix A and they have given me another matrix which is 10 times B. And here in that 10 times B, I have a value called alpha which is unknown. And they're saying that B is A inverse. B is A inverse. Then find the value of alpha. Let me first ask you how to find the inverse of a matrix. How to find the inverse of a matrix? Everybody can say it's adjoint of A by the determinant of A. Simple formula, adjoint of A by determinant. So first let me start with the determinant of A. I believe everybody knows how to find the determinant of a 3 by 3 matrix. Yes, the first element 1 is multiplied with its cofactor 1 plus 3, 4. The second element minus 1 is multiplied with its cofactor 2 plus 3, it's minus 5, the cofactor. And the third element is 1, which is again multiplied with its cofactor 2 minus 1, it's plus 1. The first one has cofactor positive 4, the second one cofactor minus 5, the third one cofactor plus 1. Every element in the first row is multiplied with its corresponding cofactors. That's equal to 4 plus 5 plus 1 equal to 10. You need not follow this method of element with cofactor and all. You know how to do the determinant. Simply cross multiply, put the correct signs, plus, minus, plus. You know to do it, just put it and just keep doing it. Okay, I was just saying the actual definition of a determinant. Every element in a row or every element in a column is multiplied with its corresponding cofactor and added. Then you will get the value of the determinant. Okay, it's 10. Now let me go for finding adjoint. Adjoint of A is actually cofactor of A, the whole transpose, right? First of all, let me find the cofactors of A. It's a long process. I believe everybody knows how to find the cofactors of A. I am just straight away writing the cofactors, all of you. Okay, for the first one, 1 plus 3, 4. The second one, 2 plus 3, 5 is negative 5. Third one, 2 minus 1, it's 1. Fourth one, it's minus 1, minus 1, minus 2, cofactor 2. Fifth one, 0. Sixth one, plus 2 with a minus sign should be applied, minus 2. Sixth one, 2. Seventh one, minus 3, minus 2, minus 5. A sign should be applied, 5. And then 1 plus 2, 3. So these are the cofactors of A. Please, I believe everybody knows to do it, so I'm not wasting my time finding it. Okay, quickly all of you learn. You can easily find the cofactors by simply from the matrix you keep on eliminating the corresponding row and column, cross multiplied, put the correct sign It's alternate signs, plus minus, plus minus, plus minus. You can do it, okay? So you can, but please you follow the original method, not wasting the time on that. Cofactors. Therefore, what's adjoint of A? What's the adjoint of A? The transpose. 4, 2, 2, minus 5, 0, 5, 2, 5, 3. So I got the adjoint of A. Now what's A inverse? What's A inverse? The adjoint of A divided by the determinant of A. And the adjoint of A is, and we know A inverse is B. Okay, A inverse is given to be as B. B is equal to 1 by 10 into the matrix I got is 4, 2, 2, minus 5, 0, 5, 2, 5 and 3. This is my matrix, my dears. You can easily compare this with the situation given in the question. The question clearly says 10B is equal to that. So if I take this 10 to the left side, 1 by 10 of the matrix, can you see the exact same matrix has appeared over here? Yes? So please compare the position and you can see alpha is 5. What's the value of alpha? Yes? All of you clear? What's the value of alpha now? That implies alpha is equal to 5. Okay? I just found the inverse and I compared that inverse with the given matrix because they said that A inverse is B. Clear? All of you? Yes? Okay, fine. Inverse of a matrix from the chapter 3 is deleted by using method of elementary transformations, but finding the inverse using method of determinant is still applicable, so we have to learn it. A inverse is equal to adjoint of A by the determinant of A. Okay, clear, Vigneshwaran? Okay, fine. Now I'm going to the next question. Find the unknown matrix X. Find this unknown matrix X, which is going to be multiplied with another matrix to get a third matrix. So here the problem is it's not a square matrix. For example, if I'm multiplying X with A and I'm getting the answer B, and here A and B both are square matrices, then it is pretty easy, my dears. It's pretty easy because if A and B are square matrices, you don't have to worry about what is X. You can say that X is equal to B into A inverse. X is equal to B into A inverse. And you can find A inverse. If it's a 2 by 2 matrix, A inverse is very easy to find. Adjoint of a 2 by 2 is very easy to find. We have a shortcut method. You can just refer to the YouTube video for MCQs. You can get that shortcut over there. 2 by 2 matrix or a 3 by 3 matrix. Just now we did how to do the A inverse. Yes, so this is applicable only if A and B are square matrices. But in this case, A and B are not square matrices. They are a matrix of order 2 by 3 and the result is also 2 by 3. If I have to multiply a X with a 2 by 3 to get another 2 by 3, then definitely X should be of order 2 by 2. No other choice. Because to multiply two matrices, the number of columns in the first matrix should be equal to the number of rows in the second matrix. So here 2, so here definitely the number of columns should be 2. And the result of the matrix that is obtained after the product should be of rows from here and columns from here. So the result is 2 by 3. So this 2 should be over here. Understood? So the result of the product is rows of the first matrix, columns of the second matrix. The idea behind this is also explained in the MCQ discussions, my dears. And it's a very common question in MCQs to find the order of the products. What is the order or what are the possible values of the order of the product if two matrices of this particular order is being multiplied? So it's a very common question in MCQs. Please go and refer to it. Okay, so here I have understood that X has an order 2 by 2, so I assume the values as A, B, C, D. Okay, 4 values. Got it? So we're going to be trying to multiply this ABCD with that. Yes? So ABCD is multiplied with 1, 2, 3, 4, 5, 6 is equal to minus 7, minus 8, minus 9, 2, 4 and 6. I'm trying to find out 4 unknown values of ABCD. And I believe you know how to multiply two matrices. The first row multiplied with the first column, you will get A plus 4B. The first row multiplied with the second column, you will get 2A plus 5B. Don't go any further. Don't go any further. The first element we know is negative 7. The second element we know is negative 8. So I got two equations in terms of A and B. Just simply solve them using method of elimination. You will get the values of A and B. So I'm just trying to solve the two equations, my dear students. Okay, so just for the first equation I'm multiplying a 2. So I will get 2A plus 8B equal to negative 14 and 2A plus 5B equal to negative 8. Use method of elimination. Negative sign, it will cancel. Negative sign, 3B. Positive sign, it is minus 6. So B equals negative 2. I got the value of B, negative 2. No need to write everything. They're asking me to find what is ABCD. So I just multiply the first row with the first column. I got an equation A plus 4B equal to the first element minus 7. 2A plus 5B, the second element minus 8. Solve the two equations, you get the value of B. Now, substitute in any equation you want. A plus 4B equal to negative 7 and A is equal to minus 7 plus 8, which is equal to 1. So I got the value of A, I got the value of B. Now, the same technique please apply with C and D. When CD multiplied with the first column, you get C plus 4D equal to the first element in the second row, 2. CD multiplied with second column, 2C plus 5D equal to 4. Again two equations, solve it. The same idea, multiply the first one with 2, you can get using method of elimination. 2C plus 4D equal to 4. 2C plus 5D equal to 4. I can eliminate. I will get minus D equal to 0. So I got the value of D as 0. The value of D is 0. Substitute that somewhere. C plus 4D equal to 2. D is 0. So I can say implies C is equal to 2. Implies C is equal to 2. Very good, Dhruvil. Right answer. Okay. From this we can conclude what's the final answer for the unknown matrix X. X is equal to A, which is 1, B, which is minus 2, C, which is 2, and D, which is 0. Very good question for 2 marks. Because it's 2 marks, no need to show the product. Don't write everything and waste your time. Just take the required equations from the product and simply solve for A, B and C and D. Okay? Got it? I believe everybody is clear. Yes or no? So can we move on to the next question? First, most important thing about this question is to identify what should be the order of X. It's a very, very important technique, identifying the order of X. Okay? Fine. Good. Question 6, all of you. This is again a very important type. I have tried to mix 2 important questions in this. One is finding the unknown value K in this expression. Finding the unknown value K in a matrix equation. What is the matrix equation here? A squared is equal to Ka minus 2i. This is the matrix equation. From this I have to find out what is K. I am given what is A. Here, what is A squared, all of you? A squared means I am trying to find the product of a matrix 3 minus 2, 4 minus 2 with itself 3 minus 2, 4 minus 2. Do the product, all of you. You will get 9 minus 8, minus 6 plus 4, 12 minus 8, minus 8 plus 4. So the product is 1 minus 2, 4 minus 4. This is a squared. Okay, and I'm now using this a squared in the equation. So the a squared equation is 1 minus 2, 4 minus 4. Multiply k, which is a scalar value, with a. So you will get 3k, negative 2k, 4k, negative 2k, minus 2 times I. You know an identity matrix, right? 1 0 0 1, multiply with 2, 2 0 0 2. You have to take the 2 by 2 identity matrix because the question is 2 by 2. Okay, now from this I'm supposed to find the value of k. So can I say that the first element here is 1, and that when compared to the right side is 3k minus 2. The first element on the right side is 3k minus 2, and the first element on the left side is 1. Solve, please. 3k equal to 3, k is equal to 1. This alone is a very good question to be asked. Find an unknown value from the matrix equation. Find the unknown value from the matrix equation. Now I got the value of k, so what is my equation? What is my equation? Hence equation is, what is my equation, all of you? A squared equal to 1k, 1a, which is a, minus 2i. This is called a matrix equation. What is this called as? A matrix equation. Very good answers, Faris, Sana and Loyal. Okay, we got the value of k as 1. Good. Now this matrix equation can be used to derive an expression to get A inverse. That's a second question. I would say these two are different questions. I am not expecting both of them to be coming together. Two different questions. But from a matrix equation, how to find A inverse? It's simply multiply the entire matrix equation with A inverse. Multiply the entire matrix equation with A inverse. What happens if A squared is multiplied with A inverse? It becomes A raised to 1. And when A is multiplied with A inverse, product of a matrix with its inverse is always I. If you want, I will write those properties here. If you multiply any matrix raised to n with A raised to minus 1, you will get A raised to n minus 1. If you multiply any matrix with its inverse, you always get I. And if you multiply any matrix with I, you will get the matrix itself. And if you multiply any matrix with a 0 matrix, the answer is always 0. Please keep in mind, these are very good products which can come in simplifying a matrix equation. So when I multiply A squared with minus 1, it becomes A raised to 1. If I multiply A with A inverse, it's I. And if I multiply I with a matrix, I will get the matrix itself, 2A inverse. So A dash, it's A raised to 1, okay? It's A raised to 1. So can I say 2A inverse is equal to I minus A? And from this, what is A inverse, my dear students? It is I minus A divided by 2. This is how you find the inverse of a matrix from a matrix equation. It's a very important question for you. Please learn it. If they give you the matrix equation, simply multiply A inverse throughout and you can reduce it to an equation to get the inverse of a matrix. Okay. Now I minus A, it's a simple matrix, right? What is I minus A, all of you? Please look at the question here itself. What is I minus A? I minus A, 1 minus 3 minus 2, 0 plus 2, 2, 0 minus 4 minus 4, 1 plus 2, is 3. So this is my I minus A. Yes, so I have to divide it with 2. So my A inverse is equal to minus 2 by 2 minus 1. 2 by 2, 1. Minus 4 by 2, minus 2. 3 by 2. So this is my A inverse. This is my A inverse. I want everybody to go through it. So what if you find the inverse normally? Why do you want to find the inverse normally when you have such a simple technique here? Okay? Why do you want to find the inverse normally? They are saying hence find inverse. If you find the inverse normally, you get the same answer. What is the meaning of the word hence? Means use this approach of this matrix equation to find the inverse. They will give you half mark for the correct answer. They will take away all your marks for the steps. Don't do it. When the word hence is given, use what you did in the first step to do the inverse. Otherwise, you will not get marks. Okay? Fine. So moving on to the next question, my dear students. Yes. I think everybody has practiced this question n number of times in your regular classes. To solve a system of equations with 3 unknown variables using matrix method. The most anticipated question for 5 marks. Okay? So everybody would be thorough with the simple technique. Yes? From this, can you tell me what is your matrix A, which is formed using the coefficients of the equations? 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. And you can use matrix B, which is the right hand side of the equation 4, 0 and 2. And you can then use another third matrix X, which is X, Y and Z, the unknown values or variables in the system of equations. So I got 3 matrices from the system of coefficients of the equations, the system of matrix which is the right hand side of the equations, and this is the unknown variables. So this system actually is matrix A multiplied with X equal to B. And from this we can say X is A inverse multiplied with B. And we all know what is A inverse. A inverse is adjoint of A multiplied with B divided by the determinant of A. So we have to find the adjoint multiplied with B divided with determinant. So first of all, let me find what's the determinant. What is the determinant of A? 1 with 4. Again 1 with 5. Again 1 with 1. So the determinant of A is 10. What is the determinant of A, all of you? 10. If the determinant of A is 10, I have explained this again in the system of equations test for consistency MCQ discussion. Please go and watch it. It's very important. Only if the determinant is non-zero will you be able to tell a unique solution for X, Y, Z. Only if the determinant is non-zero. Here I can say it's non-zero determinant, hence the system has a unique solution. Okay? Can we multiply inverse to big equations involving A cubed? Yes, definitely. When you multiply with A cubed, it reduces to A squared. Okay, it reduces to what? A squared. And then you have to rearrange that equation and get an expression for A inverse from that. So wherever I is there, I will become A inverse. Okay, got it? So that's what you have to keep in mind to rearrange it. Okay, Vignesharan? Fine. Now, how to solve this? You have to go for finding the adjoint of A. And we know that adjoint is what? We know that adjoint is equal to cofactor matrix transpose. Yes, cofactor matrix transpose. Now, those who are not familiar with this technique of finding the cofactors can do it now. Just write this A matrix 4 times. 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. Again, once more, 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. Again, right below it, 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1, 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. Okay, I've just written that same matrix 4 times. Okay, got it? Now this is one shortcut technique to find the cofactors without any confusions of what to cross multiply, how to eliminate rows and columns, what correct sign should I put in front of it, plus, minus, no confusions. This method simply gives you the answer straight away. So please, that's why write the matrix 4 times and then take out the border values of this. Okay, take out the border values. Then start cross multiplying here. Okay, the first cross multiplication will give you 1 plus 3, 4. The second cross multiplication will give you minus 3, minus 2, minus 5. The third cross multiplication will give you 2 minus 1, 1. Like you do for determinant. Simply keep cross multiplying. Simply keep cross multiplying. Yes, you can use this method, no problem. Okay, you can use this method. 1 plus 1, 2, 1 minus 1, 0, because here it's not to find the adjoint. The question is not to find the adjoint. The question is to solve the system of equations. So they do not care on how you found the cofactors. Cofactors is a method to find the adjoint of a matrix. You just get the cofactors correct. Okay, that's all. So minus 1, minus 2. Then 3 minus 1, 2, then 2 minus 2 plus 3, 5, okay, and then 1 plus 2, 3. So I did not bother about the sign, nothing. I simply cross multiplied and I got the cofactors. I simply cross multiplied and I got the cofactors. Now, how to write the adjoint? What is the adjoint, all of you? Come on, adjoint is the cofactor transpose. Adjoint is equal to what? Cofactor. Adjoint is equal to cofactor transpose. Get the transpose, all of you. 4 minus 5, 1, 2, 0, minus 2, 2, 5, and 3. Yes, I got the cofactor transpose, I got the adjoint, all of you. Now, put it in that. Adjoint of A should be multiplied with B and divided with the determinant. Okay, so adjoint of A, all of you. What was the adjoint of A? Come on, quick. What was the adjoint of A? Adjoint of A was 422 minus 505, 422 minus 505, and the last one was 1 minus 2, 3. 1 minus 2, 3. It's multiplied with B. Adjoint of A should be multiplied with B. B was 402. B was 402. So if you multiply it, you will get 16 plus 0 plus 4 minus 20 plus 0 plus 10, 4 plus 0 plus 6. So my product is 20 minus 10, 10. And that is again divided with the determinant. X is adjoint A multiplied with B divided with the determinant. If that is divided with the determinant 10, you will get 20 by 10 minus 10 by 10, 10 by 10. The value of x, y, z, please. That implies x is equal to 2, y is equal to -1, z is equal to 1. This is your solution for the system of equations. So once again, yes, Faris, right answer. 2 minus 1 and 1. So what's the method to find the solution for a system of equations? X is equal to adjoint of A. That should be multiplied with B and divided with the determinant of A. Okay, and for finding the adjoint, we have to find the cofactors and take the transpose. And this technique over here is a technique to find the cofactors very fast, without confusions, without mental strain of thinking about what row and column to eliminate, and without any mental strain of what sign to be multiplied with each element of the minor. Okay, clear all of you? Just write the matrix 4 times, take out the borders of the matrix, and then cross multiply each 4 elements. You will keep on getting 1 cofactors, no doubt, and then take the transpose of that, you will get the adjoint, and then multiply the adjoint with B and then divide by determinant. Don't divide with determinant, find A inverse and then multiply with B. It is going to be difficult because you might take the 10 inside and make the numbers into a fraction, and then multiplying with B will result. So if you divide this with the 10 and then try to multiply 402, you will be trying to multiply with fractions. Complicated. So you have to multiply with B first and get them into perfect numbers, and then those 3 numbers should be multiplied with the value of the determinant. I hope everybody is clear with this question. Yes? Okay, fine. Okay, fine. Question number 8. Question number 8, you can see that it's reciprocals of x, y, z. So here, I'm not trying to solve this actually. I'm not trying to solve this. You have to say that u is equal to 1 by x, v is equal to 1 by y, w is equal to 1 by z. I'm calling this x, 1 by x, 1 by y, 1 by z as u, v and w. And I'm going to rewrite my equation as 2u plus 3v plus 10w equal to 4, and 4u minus 6v plus 5w equal to 1, 6u plus 9v minus 20w equal to 2. Now I have made it into a system of equations with 3 unknown variables in the normal way. And you will again call matrix A as the same procedure: 2, 3, 10, 4, minus 6, 5, 6, 9 and minus 20. And matrix B, the right hand side, 4, 1 and 2. And X as X, Y, Z. This is how you create the 3 matrices, and you know how to solve it. Sorry, it's not X, Y, Z. It's U, V, W. It's U, V, W. You will get some values for U, V and W. Okay? Like the same old process for the previous question, you will get some values for U, V, W. You just have to take the reciprocal. At the end, take reciprocals of U, V, W to find X, Y, Z. Because X, Y and Z are the reciprocals of U, V, W. So I don't want to do this again because the process of finding U, V, W is similar to what we did in the previous question. So you can just use the previous method, get what is U, V, W and take the reciprocals of U, V and W to find what is X, Y and Z. Okay? Got it? Any doubts? Fine. Question number 9. Normally, again, this is one question you have done in class so many times. They ask you to find the inverse of a given matrix and hence solve the system of equations. Like I said before, when the word hence comes, what is the meaning of that? You have to use whatever you did in the first step to solve the system of equations. How to find A inverse? Everybody knows. It's adjoint of A divided by the determinant of A. So here let's try finding the determinant of A quick. Here determinant of A is equal to 1 into 1 plus 3 plus 1 into 2 plus 3 plus 1 into 2 minus 1. Again the determinant is 10. I use the same matrix again and again because it will be easy for us to calculate. Okay, that's why I'm using the same matrix in the same system of equations. So I got the determinant as again the same matrix, so determinant is 10. And to find the inverse, we already know how to do this. I'm going to go and check that inverse, not wasting my time. I'm going to check that inverse, yes. For the same matrix, 1 minus 1, 2, 1 minus 3, 1, 1, 1. The adjoint is 4, 2, 2, minus 5, 0, 5, 1 minus 2, 3. Adjoint of A, we already did the same thing, that's why I'm going and taking it 4, 2, 2, minus 5, 0, 5, 1 minus 2, 3. Just checking it once again. 4, 2, 2, minus 5, 0, 5, 1 minus 2, 3. So this is my adjoint, all of you. Okay, so I got my A inverse, I got my adjoint, and what is my A inverse, all of you? Therefore, A inverse is equal to, don't take the 10 inside. Don't take the 10 inside, please. Leave it out. You can just show that there is a 10 which is being multiplied outside, 1 by 10, and this is my A inverse. And the question is, use this A inverse to solve this system of equations. Okay, now let's look at the system of equations given to us here. From the system of equations, from the system of equations, from the system of equations, I will get a matrix from the coefficients 1, 2, 1, minus 1, 1, 1, 1, minus 3 and 1. And I will get a right hand side values matrix 4, 0 and 4. And I will get a matrix with unknown variables x, y, z. Normal question would be, this same matrix would be the matrix here also. 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1 should have been here also. But you can see that this matrix is not the same. Normal question where they give you to find A inverse and hence solve it would be having a matrix, an exact same matrix in the system of equations. But in this case, it is completely different. It is not the same matrix. Okay, but can anyone tell me what does this matrix look like when compared to A? Can anyone tell me? Look at A and look at the matrix we got from the system of equations. Can anyone tell me how do they look or anything relatable there? Anyone can try. Very good, Faris. It looks like the transpose of A. That's how they're going to be confusing you in the board exam. They will ask you to find the inverse and then solve. Normal textbook question is matrix A and the system is also matrix A. So you don't have to worry. Use that inverse and solve the system straight away. A inverse into B. A inverse multiplied with B will give you the solution. Yes, X is equal to A inverse into B. So if this matrix is the same system of equations, you multiply the inverse with B, answer over. Okay, but in this question, it's not like that. It's transpose. So if I have to find the inverse of this, all of you, if I have to find the inverse of this, therefore, X is equal to A transpose inverse into B. A transpose inverse into B. Because, what is the reason? Because the system is A transpose. A transpose inverse, this matrix inverse should be multiplied with B to get the value of X, Y, Z. And we should know the property that A transpose inverse is same as A inverse transpose. A transpose inverse is same as A inverse. So you don't have to do anything new. Learn that A transpose inverse is same as A inverse transpose, and we already know what is A inverse from the calculations we did. Just take the transpose of that A inverse, that is going to be 1 by 10. Take the transpose of A inverse from that. So 422 minus 505, 422 minus 505, 1 minus 2, 3 will be multiplied with B, which is 404. Please multiply it quick, all of you. You will get the answer. 16 plus 0 plus 4, 8 plus 0 minus 8, and 8 plus 0 plus 12. So your matrix is 1 by 10, 20, 0 and 20. 20, 0 and 20. Therefore, x equal to 2, y equal to 0, z equal to 2. Please beware. If they ask you to find inverse and hence solve, normally the inverse of this, the matrix A given in the question will be the exact same matrix obtained from the equations. But it's a confusing question when it is not the exact, it's transpose. So you don't have to do anything new. You find the inverse of A, and when you're trying to find the inverse of A transpose, simply find the transpose of the A inverse you got before and multiply it with B. I believe everybody is clear with this question. I believe everybody is clear with this question, right? Yes? Very important, please learn it. Solving a system of equations everybody is familiar with, but there are questions like this which will confuse you in the exam. We do not want to lose this 100% sure 5 marks which we will get from the examination. Okay, so A inverse, clear it all of you. Okay, next question please. P is given, Q is given. You have to find the product PQ and then solve the system of equations. Let's find what's PQ. PQ means the product of minus 4, 4, 4, minus 7, 1, 3, 5, minus 3, minus 1 is multiplied with 1, minus 1, 1, 1, minus 2, 2, 2, 1, 3. Please multiply it, all of you. When you multiply it, it's minus 4 plus 4 plus 8. 4 minus 8 plus 4. So you will get, I'm not wasting my time to multiply, you will get such an answer, all of you. You can check the multiplication. You can check the multiplication of P and Q. You will get an answer like this. So whenever they ask you to find the product of two matrices and hence solve the system of equations, the product will always result in something like this. And we all know that this is the identity matrix. The only change that's going to come in the product is the number 8. The number 8 can be anything. It can be a negative number, it can be a positive number, it can be even 1 also. That is, it will be straight away I. So we are not going to be concerned about the 8. We know that the product is 8i. It's much easier to do a question of this pattern than even our normal question of solving a system of equations, which has to do a hectic calculation with adjoint, inverse, determinant. So many things are going on there. Here, nothing needed to be done. Nothing is needed to be done here, my dear students. Okay, so here it is much easier to do when PQ is equal to 8i. Now I'm going to solve the system of equations, hence solve. So you have to use this product to solve it. So let me see, what's my A? What's my A? 1 minus 1, 1. 1 minus 2, minus 2. 2, 1, 3. This is my A. Okay. Now what's my B matrix, the right hand side matrix? 4, 9, 1. And my unknown matrix, x, y, z. Okay, now I'm ready to solve this now. If you solve this using the normal method of an A inverse, determinant and all, you might get only the marks for the final answer. For the steps, 0. They will not give you any marks if you do the normal method for solving this. You have to use this product. How to use this product? I can make a small comparison here. All of you look at A and look at the two matrices given in the question. You can clearly see that the matrix A is actually the matrix Q itself. What is matrix A, all of you? It's Q. Matrix A is Q. Then what is A inverse? Q inverse. What is A inverse? Q inverse. Matrix A is Q, then A inverse is Q inverse. Also, P into Q equal to 8i. We know that the product of P and Q is 8i. Can I say that implies P by 8 is equal to Q inverse? P divided with 8 is equal to Q inverse. Forget about I, because when I is multiplied to any matrix, it's the matrix itself. So Q inverse is equal to P by 8. That's the most powerful conversion. Substitute that over here. So what is A inverse? Which is Q inverse, which is P by 8. So I'm literally not finding the inverse of the matrix here. I, by using the product relationship, establish that Q inverse is P by 8. Q inverse is P by 8. Use that and solve. X is equal to A inverse into B. And A inverse is P by 8 into B. And we know what is P, we know what is B. Multiply it. Multiply it. P is minus 4, 4, 4. Minus 7, 1, 3. 5, minus 3, minus 1. Multiply it with B. B is 4, 9, 1. Okay? All of you? Clear, all of you? How do you find that multiplication at start? It's always the product of two matrices is asked and solve the system of equations. The product will always result in an identity matrix. But as number may come with it, just take the first row, the first column. I got the number 8, so I understood that it's going to be 8i. The first element is enough. If the first element was 1, I did not say anything, it will be directly I. PQ is equal to I, because the first element is 1. Got it? Clear? Okay, fine. So you just multiply it. 1 by 8 minus 16 plus 36 plus 4 minus 16 plus 36 plus 4 minus 28 plus 9 plus 3, then 20 minus 27 minus 1. The first one is 40 minus 16, 24, 24 by 8, 3. 9 plus 3, 12. 12 and minus 28 is minus 16. Minus 16 by 8, minus 2. 20 minus 28, minus 8. Minus 8 by 8 is minus 1. So I got the values of x, y, z. X is equal to 3. Y is equal to minus 2. Z is equal to minus 1. This is the answer. I think everybody understood this idea. Yes or no? The product of two matrices and hence solving it. If you find the product, you always get an identity matrix and hence use that product to solve it. Yes, my dear students, any confusions, please tell. Any confusions you can put in your chats. I can clear it for you. Because we have done with solving a system of equations. No more methods. 3 types. Standard question, reciprocal, inverse, and then one more, the product. Total 4 types. A standard question is easy. Reciprocal, substitute each reciprocal as a new variable. Third one, find inverse and then solve it. So normally inverse would be of the same matrix, but if it is a transpose matrix, just take the transpose of that inverse you get. And then product and then solving. Okay? I think everybody is clear. Yes, good. Moving forward, all of you. Now this is again one more question which you can practice. Okay, I'm not going to do it again. It's a product. So I'll just show you the product alone. I multiply 1 and minus 2. So it's minus 2. Minus 1 and 9. It's minus 9. 6 2s are 12. Okay. So I can see that it's 1. The first element is 1. So I will say that here the product PQ is straight away I. Not 8i. It's I. And from here, the system of equation 1 minus 1, 2, 0, 2 minus 3. Look at this. So here, the system of equations A is same as P. So A inverse is equal to P inverse. A inverse is equal to P inverse. So from here, Q is equal to P inverse. Because if I take P, it becomes Q is equal to P inverse. Got it? It's not like taking P to the other side. It's like multiplying P inverse on both sides. P inverse into P is I, and I into P inverse is P inverse. So Q is equal to P inverse. So I can simply say A inverse is equal to Q. No calculations. A inverse is straight as Q. So this is your A inverse. This whole matrix over here will become your A inverse. This whole matrix is your A inverse. Pretty easy question to get. Please, you all have to expect that this question is going to come because it is easy to solve. Getting the product and getting the inverse and solving the system of equations. Okay, fine. Now this, I put few questions where they will not give you the system of equations, but you have to form the system of equations. So maybe if they want to make it twisted in the exam hall, maybe they're giving you a word problem and want to create the system of equations from you, then they can ask questions like this. The sum of 3 numbers. So let's assume x comma y comma z are 3 numbers. The 3 numbers are what? X, Y, Z. The sum of the 3 numbers is 6. So I got the first equation. The sum of the 3 numbers is 6. If we multiply the third number with 3 and add the second number to it, multiply the third number Z with 3 and add the second number to it, we get 11. Second equation ready? So that means here the x is 0. X is 0. By adding the first and the third numbers, we get double the second number. Add the first and the third number, we get double the second number. So from this, can I say x minus 2y plus z equal to 0? Finished. This is how I get a system of equations. I don't think it's going to be a complicated one because solving a system of equations alone is 5 marks. So how difficult can they make for word problems to form an equation? So please, straightforward numbers will be there. You should be smart enough to tell what is x, y, z and how to relate a particular number with x, particular number with y and a particular number with z. That's all. Okay? Got it, all of you? Yes? Fine. So this is, again, you have to solve this using matrix method. A inverse into B. Okay? Fine. Next, read question number 13, all of you. I have the cost of 4 kilograms of onion, 3 kilograms of wheat and 2 kilograms of rice is rupees 60. The cost of 2 kilograms onion, 4 kilograms of wheat and 6 kilograms of rice is 90. And cost of 6 kilograms of onion, 2 kilograms of wheat, 3 kilograms of rice is 70. Find the cost of each item per kilogram. Okay, so x comma y comma z is the cost of each item per kilogram. So I can assume x is the cost of 1 kilogram of onion, y is the cost of 1 kilogram of wheat, and z is the cost of 1 kilogram of rice. So I have 4 kilograms of onion. So 4x will be the cost of 4 kilograms onion and 3 kilograms of wheat and 2 kilograms of rice. Total cost is 60. 2 kilograms onion, 4 kilograms wheat, 6 kilograms of rice is 90 rupees. 6 kilograms of onion, 2 kilograms of wheat and 3 kilograms of rice. Total cost is 70 rupees. So this is the system of equations I formed. Yes, so you just have to use the numbers in the question, simply relate them with what's x, y, z. It will give you the 3 equations. So just to be on the safer side. Just to be on the safer side. Okay? Next question. One more. Shravan is a nutritionist. He wants to create a mixture of orange juice, beetroot juice and kiwi juice. So he's making a new mixture of orange, beetroot and kiwi that can provide 1860 milligrams of vitamin C. So the mixture should provide me 1860 milligrams of vitamin C. So how much orange juice, how much beetroot juice, how much kiwi juice should be mixed so that I get 1860 milligrams of vitamin C, 22 milligrams of iron, 760 milligrams of calcium. They are giving me the quantity of vitamin C in each juice, iron in each juice and calcium in each juice in this table. Okay? Now I have 500 milligrams of vitamin C in orange juice. So let me mix 500x plus 20 from beetroot juice and 800 from kiwi juice. This should not exceed 1860. Finished. Simple equation. Vitamin C combined should be 1860. So I'm taking vitamin C from orange juice, vitamin C from beetroot juice, so vitamin C from kiwi juice. I'm saying let x, y and z be the quantity of each juice in the mixture. Quantity of each juice, each per liter. Okay. Next one, 2x plus 5y plus 3z equal to 22 iron. Then 100x plus 120y plus 200z equal to 760. Okay, so I just used again the numbers with x, y, z. I know the total quantities for vitamin C, iron and calcium. So I form the equation respect to vitamin C, equation respect to iron, equation respect to calcium. That's what. I think everybody is clear with this chapter. Yes, again I'm telling you the MCQ based questions are available with you in the YouTube channel. Please go through it for matrices and determinants. So, and this is the subjective questions. We are only expecting one 5-mark question coming from this topic and maybe a 1 2-mark or a 3-mark depending on how they want to play with it. 1 2-mark or 3-mark. I have discussed almost all the important 2-mark and 3-mark which may come from this topic. Okay, I believe everybody is clear. And now moving on to LPP now. LPP is simply solving a system of equations, inequalities using the constraints. Yes, and I've also included few MCQs because I was not able to do MCQs in LPP, so I have included the MCQs of LPP in this discussion. Okay, so let's go on, all of you. First one, solve the following LPP graphically. The objective function, minimize z is equal to x plus 2y. Subject to constraints 1, 2 and 3. And from my experience I'm seeing is everybody or most of you are making one mistake or the other in drawing the graph. So I'm going to teach you a method to draw the graph without a mistake. I want everybody to be careful with it. So matrices, can they ask for case study? Yes, they could. They could ask for case study. That's why I put word problems there. What they can ask for case study is only word problems. So just have to put the numbers into a matrix, that's all. But it's not likely to be asked. But even if they ask, it is going to be a word problem like what we discussed. Okay? Fine. So now please follow this method without any doubts. The first equation is, forget about the inequality, x plus 2y is equal to 100. Now, to draw the line, you might have been taught many methods in school, but please, this is the most suitable one. Do not go in search for some random points. Go in search of points on the axis, please. Do not go in search. I have seen papers where students are going for some random points because the school teachers would have said that take some random points to draw the line, because you are drawing it on a graph paper. But that makes it more difficult for you, because when you shade the feasible region, most of the times the feasible region lies along with the axis. So the feasible region's corner points will be the points on the axis. So we do not want to take a chance there. Let us draw the lines using points on the axis. So for that, just put x equal to 0 in this equation. You will get y is equal to 50. Put y is equal to 0 in this equation, you will get x is equal to 100. Finished. X equal to 0 means it's a point on y-axis. Y equal to 0 means it's a point on x-axis. Just get 2 points to draw it. And what are the 2 points? 0, 50, 100, 0. That's the first equation. Now, wait for the second equation. To make it more clear, let me go for the third equation. 2x plus y equal to 200. Box again. Put x equal to 0, y is 200. Put y is equal to 0, x is 100. The point is 0, 200, 100, 0. 2 lines. And the points on the axis is ready. Yes, got it. Now the third one, again it's the second equation actually. Again it's a case of mistakes for many of you. Not in drawing the line. You will draw the line because you can just take some random points, you will draw it. But when you start shading, you make mistakes. X equal to 0, x equal to 0, y is also 0. That's the biggest problem here. It's a point on the origin. So this line passes through the origin, not on axis some points, it's on the origin. So it's a very confusing line. So you can randomly take any point you like. Maybe I will take y is equal to 100. Because the other numbers are like hundreds and fifties. Y is equal to 100, x is equal to 50. Okay, just to draw the line without a confusion. So this particular line is very dangerous because the simple reason it has 0 on the right side. The constant on the right side is 0, dangerous. If it's some other number, it's easy to get points on the axis. But if it's a 0, it's dangerous. So please mark this as a potential constraint for LPP. Potential constraint for LPP where the right side is 0. So now we're going to graph this. I'm not having a graph paper, but I'm going to draw a rough graph with this. Okay, the first point 0, 50. I'm not going to plot it perfect. 0, 50. Okay, next one 100, 0. 100, 0. Okay, next point, first line done. I'll draw the line. Okay, second 0, 200. 0, 200. So 0, 200 somewhere over here, and 100, 0. Same point. Second line also completed. Now the third line, it starts from origin, and the second point is somewhere in 50 and 100, somewhere over here. Okay, it's a rough diagram, my dears. I'm not drawing a perfect diagram. I need not draw a perfect diagram also. I got this graph. The graph is perfectly drawn. I think everybody understood how each line came. Now to find the feasible region, the best way to find the feasible region is check it with origin. Check each equation with origin. What happens if I put x is 0, y is 0? You will get greater than 100, which is false. For a false equation, you shade on the side where origin is not there. For the yellow line, you got it's false, so you shade on the side which has no origin, because origin is false. Yes? Now go for the green line, my dears. The green line is over here. 0 plus 0 is less than 200. It's true. So origin is on the true side. So true side means for this line you have to shade towards the origin. Okay, and please make sure when you're shading this, you don't have to shade it very dark. Shade it very soft and preferably only visible to your eyes. Okay, because these shadings are not important. The only shading that is important is the final feasible region. So you can shade this very softly, only visible to your eyes. Only you should know that there's a shading over there. Okay, got it? Don't make it too dark. Now for the orange line. For the orange line, again the big confusion is, you can't put origin to check. Normally origin is the point which tells true and false. You can't put origin to check. That's the reason why all of you make a mistake in shading that part. All of you make a mistake in shading that part. Okay, so please put any other point on the axis, preferably this one you can put. What is that point? On the x-axis, because this orange line has 1 0 on this side and other side there is no 1 0. So we are checking which side I have to shade. X is 1, y is 0. So 2 is less than 0 is false. Okay, it's false on the side of 1 0. For this orange line, 1 0 is a false side. So which side should we shade? The true side. Yes? I believe everybody is clear. Yes? Now, find the region where all the three shadings, the green, the yellow and the orange, are coinciding. It is coinciding over here. It's coinciding over here. That's your feasible region, and that's what you should show properly in the graph. This is what that should be visible to everybody. Show it dark. Okay, please keep in mind, all of you, do not show the other shadings properly. It's not necessary to show it. Okay, so now I got the feasible region and I'm going to name the points, my dears. Okay, I'm going to name the points. The first point over here, calling it as A. The second point, I do not know, call it as B. The third point, I do not know, call it as C. The fourth point, I do know, call it as D. That's why marking the points on the axis is important, because 2 points already you got. 2 points already you got. You just have to find 2 more points. And again, there is one mistake that happens with many students. Because they draw it on a graph paper, they try to assume the values of B and C. Do not do that. They might think that this value is at 100. Okay, maybe B is 100. Let me think like that. No, don't do it. Don't do it. You have to find B by solving the equations. B is the point made by the yellow line and the orange line. B is the point made by the yellow line, which is the first equation, and the orange line, which is the second equation. So solve these 2 equations to get B. So all of you, to find B, solve the equations, all of you. X plus 2y equal to 100. 2x minus y equal to 0. Okay, I'm trying to solve this. For that, normal method of elimination can be used. Using that, 4x plus x, 5x, 0, 100. So x is equal to 20. For B, x is equal to 20. Get y. If x is 20, 2x minus y equal to 0. X is 20, so y is equal to 40. So I got the point B, which is 20, 40. I think everybody is clear. Yes. First thing, draw the lines. Most dangerous thing is, right answer Faris, final answer is correct, drawing the line with a 0 on the right side and shading that feasible region correctly. Second one, finding the unknown points, solve the equations. Similarly, let's go to find C also. C is formed by the green line and the orange line. The green line is 2x plus y equal to 200. Orange line, 2x minus y equal to 0. So 4x equal to 200. X is equal to 50. If x is equal to 50, y is equal to 100. So I got the value of C, which is 50, 100. So this is what you have to find. All the corner points are now calculated. Now use that, all of you, in the table. What are the corner points? What are the corner points? A is 050. A is 050. B, C, D. B is, we found B 20, 40, 50, 100. 20, 40, 50, 100. C is done. D, all of you. D was 0 to 100. 0 to 100. Now substitute that in our objective function. Our objective function is x plus 2y. Substitute in the objective function x plus 2y. And what we get is the values of z. Put 0 and 50, you get 100. put 20 and 40, 20 plus 80, again 100. 50 and 100, so you get 50 plus 200, 250, and this is 400. And I want the minimum of Z, and we can see that the minimum of Z is 100. What is the minimum of Z? 100. I chose this question particularly for one important reason. Okay, if the question was for maximum of Z, you will say maximum of Z is 400, which is for x equal to 0, y equal to 200, finished. But here your minimum of Z has two solutions. It's a situation of multiple solutions. So at both A equal to 050, B equal to 2040. When this situation comes, if you leave it like this, there's a possibility you're going to lose marks, because this is not the correct answer. When multiple solution comes, you will say, hence the solution is all points on the line joining A 050 and B 2040. My dear students, I'm expecting this question for the boards this time for 3 marks. LPP is 3 marks, we know that. The 3-mark question, subjective question for 3 marks, simply solve and get the solution to it. And if it's a solution with 2 multiple solutions, then you will say that it's not 2 points, it's all the points on the line joining. How many points? Infinitely many points. How many points are there on the line joining A and B? Infinitely many points. So please, it's something very important you have to keep in mind. When there are 2 solutions for the LPP, say that it's all the points on the line joining the 2 points. Infinitely many solutions. Keep in mind, all of you, very important. Okay? Fine. So this is, for normally if it's a 1 solution question, like for maximum of Z, 400 is the maximum value, sir, and its solution is at 0 and 200. X equal to 0, y equal to 200. But this is multiple solutions. Multiple solution, you have to say it's all the points on the line joining the 2 points. Yes, all of you? I believe it's clear. Yes. Now I will do one question more from this based on unbounded solutions. Based on unbounded solutions, all of you. Okay? So please look at the question. Solve the following LPP graphically and find the optimal solution if possible for the feasible region. Now solving I will do quickly because everybody, I've explained for the first question how to draw the graph and everything. Only the unbounded part I will explain properly. Listen, so first constraint, 2x plus y equal to 8. Draw the box. Draw the box. X equal to 0, y equal to 8. Y equal to 0, x equal to 4. So 0, 8, 4, 0. The points for the first line is ready. Second line, x plus 2y equal to 10. Draw the box. If x equal to 0, y equal to 5. If y is equal to 0, x equal to 10. So x equal to 0, y is 8. If y is equal to 0, x is 4. Second equation, x is 0, y is 5. If y is 0, x is 10. Second set of points is ready. Third equation, oh, there's only 2 equations. Fine. So if you draw the graph for this, like I said before, simply draw the graph on x-axis and y-axis. Drawing the graph roughly, 0, 8 up to 4, 0. Join the line. Okay. 0, 5. Second one, 0, 5 up to 10, 0. Okay, so only two constraints, two lines. Start shading the region, all of you. The first one says 2x plus y greater than 8. I said origin is the best point to test. So if you put origin over here, you can see that 0 plus 0 is greater than 8 is a false condition. For the false condition, shade away from the origin. Shade away from the origin for the first line. For the white line, shade away from the origin. Now for the green line, please. The green line says x plus 2y, again put 0. You will get greater than 10 is again a false condition. So for the green line also, you have to shade away. Like I said, this shading, do as soft as possible. It need not be visible. The only region which should be visible is the optimal solution, or the feasible region which we need, where both the shadings coincide. And that happens in this red region. That happens in this red region over here. This should be properly shown in your graph. This is what is necessary to be shown. And you have to find the corner points of this feasible region over here. Yes, this is A, this is B, this is C. And do you see it's unbounded? It's an unbounded solution. So for unbounded solution, there's a different technique coming to that. But before that, we have to find this unknown point. Unknown point B again. Do not try to say that from the graph. Seen many students doing that. Do not try to say that from the graph. Solve the two equations, all of you. I have the two equations. 2x plus y equal to 8 and x plus 2y equal to 10. Just multiplying this with 2. So 4x minus x, 3x, 2y minus 2y, 0. 16 minus 10, it's 6. So x is equal to 2. So the first coordinate x is equal to 2. If I put x is equal to 2, what is the value of y? Y is 8 minus 4, which is 4. If I put x is equal to 2, y is 4. So the coordinates of the point B is 2, 4. The coordinates of the point B is 2, 4. Okay, all of you, I just went a bit quick with explaining this because drawing the graph, shading the feasible region, everything was explained elaborately in the previous question. So just follow the idea. Only two constraints here, so it's much easier. Okay, now using that, let me draw the table. Okay, my table is going to be having the corner points. My table is going to have the corner points here. All of you, corner points A, B, C. The first corner point A is 0, 8. The first corner point A is 0, 8. The second corner point B we calculated as 2, 4. 2, 4. And the third corner point C we calculated as 10, 0. Sorry. 10, 0, and we're going to substitute that in the objective function z. Substitute that in the objective function z. 50x plus 70y. 50x plus 70y. Substitute that. The answer is 2, 7, 8 are 56, 560. Then 100 plus 280, which is 380. This is 500. I want the minimum z. I want the minimum z that normally would be here. Yes, this is my minimum z, but this is a question of unbounded solution. Unbounded solution, my dears. Unbounded solution, repeatedly telling you, unbounded solution. You cannot conclude that the minimum of z is 380. Okay, for that, for unbounded, we have to do one more thing. That's why the question was very easy, but it's unbounded. That's how you will be made complicated during the board exam. For unbounded solution, check the line. Check the line. Z less than the minimum value. Check the line Z less than, that is, I am checking if there is any value below the value 380 for Z, because it is unbounded. So what is Z? 50x plus 70y less than 380. 50x plus 70y, that is actually 5x plus 7y less than 38. 5x plus 7y less than 38. Now you have to draw a line for this. It's a new constraint. What constraint? Z less than the minimum value. I'm trying to check if there is a value less than 380 for Z. So I'm drawing the new line now. Put x equal to 0. If I put x equal to 0, y is 38 by 7. If I put y is equal to 0, x is 38 by 5. 38 by 7, my dears. 38 by 7 is 5.30, so 5.4 something. And 38 by 5, it is 7.6. Okay, 7.6, 5.4. Now, on x-axis 7.6, on y-axis 5.4. All of you, x-axis 7.6 and y-axis 7.4. X-axis, 1 minute, just once again the point. X-axis 7.6, y-axis 5.4. X-axis 7.6, y-axis 5.4. Not this graph, right? Yeah, oh yeah. 7.6 on x-axis, 5.4 on y-axis. It's not a perfect graph, I understand that. It's a rough diagram I have drawn, but still I'm trying to get some accurate position for it, approximate I could say, and you have to join these 2 points using a dotted line. You have to join these 2 points using a dotted line. I have drawn a new line. Why dotted line? Because it is strictly less than 38. So equal to is not there. So that points on the line should not be included. And you can see that this particular line does not pass through the feasible region. The particular line does not pass through the feasible region. Okay, so you can say 5x plus 7y less than 38 does not pass through the feasible region. Does not pass through the feasible. So I just draw one more line using z less than 380, and I saw that that line does not pass through the feasible region. Hence, z is equal to 380 is the minimum value. So what is your conclusion? If you don't say this conclusion, out of 3 marks, you will lose 1 mark, 100%. So you have to show this conclusion for unbounded. That z less than 380, if it does not pass through the feasible region, you will say z is equal to 380 is the minimum value at x equal to 2, y equal to 4. But what if it passes through the feasible region? What if by chance your line that you've drawn, the dotted line, passes through the feasible region? Then you will say z is equal to 380 is not the minimum value. Then what is the minimum value? I don't know. It cannot be obtained. It's not the minimum value, and I cannot obtain the minimum value from this. Okay? I cannot obtain the minimum value, but the 380 you got is not the optimal solution. I think everybody is clear. Yes or no, my dear students, quickly. Unbounded solutions, I want everybody to tell me if the concept is clear or not. Everybody, please. Can I get responses from all of you, please? That we should be able to draw a line which tells me whether my line passes through the feasible region or not. Okay, clear all of you? 100% clear? Okay, I have put one more example question for you to practice. Later on you can come back and get the video and practice this question also. In this case, you will see that the new line you are drawing passes through the feasible region, and then you will say that the value that you got for z is not the minimum value. Stop there. Don't explain further. It's not the minimum value. That you say. And I cannot find the optimal solution because I don't know how to find. Graphical method does not give me the optimal solution. There are different other methods. I could say one method for you. Simplex algorithm is one method to solve LPP. Okay, that can be used to solve it, but you don't have to learn it. You have only graphical method. Got it, my dear students? Okay, now quickly, the dotted line part, sure, no problem. You know that I am drawing the dotted line using z less than 380, right? Okay, so I use that constraint 5x plus 7y less than 38. Like you normally plot points, you plot the points here also, but because it's fraction, you write it as decimals to get the approximate position for it. You get the approximate position on the x-axis and y-axis, draw a dotted line connecting them. Okay, clear all of you? Yes. And if this solution does not pass through the feasible region, then I can say that the z value we got is the optimal solution, and at x equal to 2, y equal to 4. But by chance, if the dotted line, like in the next example, passes through the feasible region, then you will say that the z value you got is not the optimal solution. It's not the minimum value. Please keep that in mind. Okay, thank you all of you, and I'm going to the MCQs quickly. Very simple questions. Quickly I can tell the answers. We can go. Okay, z is given to you. Find this is the objective function. Minimum of z occurs at which point? So for each point find z. For the first value, z is equal to 0. For the second option, z is equal to negative 32. For the third option, z is equal to positive 15. For the fourth option, z is equal to 12 minus 40, which is negative 28. So we saw that the z value is minimum at minus 32. Option B. MCQ question. Option B. Now it's MCQs. My dear students, if you know the answers, start giving the answers. Okay, like you normally do for the other MCQ discussions. All of you start giving answers. Okay, and very important, I am saying that I can almost guarantee you, not 100%, questions from LPP MCQs would be from what I am teaching you. Not 100%, at least if 3 are coming, 2 will be there from what I am teaching you right now. Not many questions, only something like 10 questions I am teaching. Okay, fine. Now next question, the corner points of the feasible region determined by the system are 0, 3, 1, 1 and 3, 0. I have 3 corner points for my feasible region, and the objective function is z is equal to px plus qy, where p and q are greater than 0, condition on p and q, so that the minimum of z occurs both at 3, 0 and 1, 1. So if the minimum, we have seen a question already here in the graphs, solving for 3 marks. We saw that minimum occurred at 2 points. So such a situation can come where 2 points gives you the same minimum value. Here they're saying like that, if the minimum had occurred at 2 points, can I say z at 3, 0 is same as z at 1, 1? That's why I can say minimum occurred at the same 2 points. Same minimum occurred at 2 points. Z at 3, 0 is same as z at 1, 1. So 3p plus 0q is equal to p plus q. I substituted x and y in z. I substituted x and y in z. So can I say 3p equal to p plus q? 2p equal to q. P is equal to q by 2. Option B. P is equal to q by 2. Very good. Very good, all of you. All of you started giving the right. So this is a very important anticipated question where the objective function is equal at both the points. Where the objective function is equal at 2 points. Just compare both the expressions by substituting x and y. Okay, you can easily get the relationship between P and Q. All clear? Very important question, my dear students. A very important question. Next one. Which of the following statements is correct? Every LPP has an optimal solution. Every LPP admits a unique solution. If an LPP admits 2 solutions, it has infinite solution. The set of all feasible solutions of an LPP is not a convex set. Okay, first one. Do I get an optimal solution always? Just now I said for unbounded, minimum z, if you try to find and I get a new line which passes through the feasible region, I cannot say what is optimal solution. So does every LPP give you an optimal solution? No. Every LPP need not give you. Maybe when you're trying to shade, there is no common feasible region. One says down the line, one says up the line, so you do not get a common feasible region. Problem, right? Option B, do you always get unique? No. I have got situations where 2 points give me the same value for z, hence I would say all the points on that line is optimal. Got it? So option B wrong. Option C, if there are 2 optimal solutions, then it has infinite solutions. Right answer already came from many of you. It is option C. It is option C. If an LPP has 2 solutions, it has infinite solutions. Please by heart it. For an LPP with 2 solutions, 2 points giving you the optimal solution, there will be infinite solutions on that LPP. Okay? Question 7. Draw the graph and find the maximum value of z. You might think it's very big. No, it's a simple graph. X plus y is equal to 2 is the only constraint. No other constraint. So if you try to draw the box, it's a line which passes through 0, 2 and 2, 0. It's a line which passes through 0, 2 and 2, 0. So the graph is going to be for a line which passes through 2, 0 and 0, 2. Now should I shade below this line or should I shade above this line? If I check the constraint, 0 plus 0 less than 2 is true. So origin is on the true side. So this is my diagram. Yes, and I have 3 corner points. What are the 3 corner points? 0, 0, 0, 2, 2, 0. 0, 0, 0, 2, 2, 0. Get the value of z in each case. X plus y. 0, 2, 2. I want maximum. And you can clearly see maximum occurs at 2 points. 2 solutions. 2 optimal solutions. Is obtained at only 1 point. Wrong. Obtained at only 2 points. Maybe right. But this is my answer. Why? Because if there are 2 solutions, every point on that line is a solution, right? So every point on this line is a solution. So how many points on that line? Infinitely many. So don't write only 2 points. Wrong answer. This is the 3rd question I'm explaining based on this. So understand the relevance and the importance of multiple optimal solution. Multiple means if there are 2 points where optimal solution occurs, then you should not say that it's only at 2 points. You should say that optimal solution occurs at all points on the line joining the 2 points. Very good, but a B had come, please change it. A B had come in the options, please change it, my dears. Question number 8. An objective function of an LPP is a constraint? Not at all. You know what's a constraint? It looks like an inequality and you find the feasible region using that inequality. It's a function which has to be optimized. Yes, maybe right. Question option C, a relation between the variables. Yes, none of these. So which is the best option that suits the answer? Best option that suits the answer. It's an objective function, it's an LPP, then it is not a constraint, it is a function to be optimized. It's a function to be optimized. You're trying to optimize an objective function. Yes, so please take that option. That's the answer for the definition of an objective function. Okay, this again, it's a very, very important question, my dears. Read it. The graph of the inequality. Yes, what is the inequality? 2x plus 3y greater than 6. And you all know how to plot the points. Yes. Just simply for explaining I'm plotting it. Actually you can answer it without even plotting also. X equal to 0, y is 2. Y equal to 0, x is 3. So you're drawing a graph which passes through 2 on y-axis and 3 on x-axis. So my dear students, it is greater than 6, strictly greater. So it's a strictly greater line, so it will be done with a dotted line, my dears. You cannot draw a bold line here, you have to use a dotted line. And where to shade? Greater than 6, 0 plus 0, greater than 6 is false. So origin is false. You have to shade above the line. So now you will say the explanation correct. Is it a half plane that contains the origin? No. Origin is false. That's why you rejected the points below it. It's not a half plane to get the origin. Half plane that neither contains the origin. That's correct. It does not contain origin. It neither contains the origin nor the points on the line. See, it's a dotted line. Why dotted line? Because it does not contain the line. If it's a bold line, it will contain. Why did I draw the dotted line? Because it is strictly greater than. So option B is my answer. It's half of the plane that does not contain the origin and does not contain the points on the line. Okay, is it the whole plane? Wrong, not the whole plane. Is it the entire XOY plane? No. So what's the option, all of you? Half plane. Now careful, does it contain the origin? Does it contain the points? You can decide it from the equation. Check with origin, 0, 0. If it's false, it doesn't contain the origin. Check with what? The inequality. If it is strictly greater than or strictly less than, it will not contain the line also. Yes? Clear, all of you? Okay. Yes, the same thing like we do for a normal inequality in the LPP problem. Okay? Yes. The last question. The feasible region for an LPP is always what? You have seen that feasible regions are bounded with corner points and it has straight lines on the sides. So it's a polygon. I know it's a polygon, but what type of polygon? Please by heart it. It's always a convex polygon. The feasible region that is obtained by solving an LPP is always a convex polygon. Yes, always a convex polygon. By heart it, my dear students. So I have discussed these questions with you, and next we'll be coming back again with two important topics: relations and functions, inverse trigonometric functions, at 7 p.m. today for 3 hours. So I request all of you to be attending these live sessions. It's like revision again. So you're doing these questions and practicing, which are the most anticipated question for the boards. So you can practice alone, I don't mind, but still I prefer all of you, those who are struggling especially, to attend these live sessions, and I can guarantee you at least 80 marks in your board exam out of 100. Okay, so I request all of you to be attending these sessions without fail. So see you again for the next live at 7 p.m. It will be taken by Ashraf sir. So please attend the session without fail. I want everybody to be following us daily for 3 days. Tomorrow again 2 sessions. Day after tomorrow also we'll coming back 2 sessions. We will finish this entire portions in these 3 days. Attend the sessions with us. Thank you and see you at 7 p.m. Good night.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.